April 15th, 1945. Colditz Castle, Saxony, Germany. An American war correspondent climbed into a dusty attic above the prison chapel and froze. There, assembled in sections, sat a full-size glider aircraft with a 32-foot wingspan. The wings were covered in blue and white checkered cotton. The fuselage was constructed from bed boards. And here's the contradiction that makes no sense. This wasn't a model or a toy. This was a functional two-man aircraft, complete with control surfaces, a pulley-based catapult system, and a concrete-filled bathtub designed to launch it off the roof at 30 miles per hour. The correspondent snapped a single photograph, the only image ever taken of the original Colditz cock, before Soviet occupation made the castle inaccessible for decades. But how did prisoners of war, locked inside Germany's supposedly escape-proof maximum security facility, build an aircraft from scratch without arousing suspicion? The answer reveals one of history's most audacious engineering projects. A 10-month construction effort involving 12 men, over 6,000 handcrafted pieces, and improvised tools made from bedposts and gramophone springs. This wasn't just a desperate fantasy. When a full-scale replica was tested in 2012, it flew perfectly. The prisoners' calculations had been flawless.
Colditz Castle, formerly designated O-Flag Roman IV C, wasn't an ordinary prisoner of war camp. Built on a rocky outcrop 250 feet above the Mulde River in Saxony, this medieval fortress had been converted by the Germans into their highest security facility for Allied officers. The walls rose 7 stories. Barbed wire surrounded every accessible point. Armed sentries patrolled constantly. Searchlights swept the courtyards throughout the night. The Germans sent their most troublesome prisoners here. Officers who'd already escaped from other camps, serial escape artists, and men deemed security risks. By 1943, the castle housed roughly 800 prisoners from Britain, France, the Netherlands, Poland, and other Allied nations. The irony wasn't lost on anyone. Colditz was marketed as escape-proof, yet it recorded more escape attempts than any other POW facility in the Third Reich. Over 300 attempts were made during the war years, with 32 men successfully reaching Allied territory. Prisoners had tried everything: tunnel excavations lasting months, elaborate disguises requiring forged documents, even a human catapult designed to fling a man over the wire fence during darkness. Each failure taught valuable lessons. Each success inspired new attempts. But what they didn't know was that 3 British officers were planning something unprecedented. Flight Lieutenant Bill Goldfinch, an RAF pilot captured in Greece, possessed engineering knowledge and had studied aeronautics. Flight Lieutenant Jack Best, Goldfinch's closest friend, was a skilled craftsman with mechanical expertise. Lieutenant Tony Ralt, a tank officer captured in the Western Desert, had the organizational mind needed to coordinate a project this ambitious. In early 1944, they began discussing an idea that seemed absurd. If escaping through the ground or over the walls had proven nearly impossible, why not escape through the air?
The engineering challenges were staggering. First, they needed to design an aircraft capable of carrying 2 men approximately 200 yards, far enough to clear the castle walls and land beyond the German perimeter in the valley below. This required calculating lift coefficients, wing loading, and glide ratios without access to textbooks, slide rules, or any standard aeronautical reference materials. Goldfinch worked from memory and basic physics principles he'd learned years earlier. Second, they had to source materials inside a prison where everything was counted, inspected, and monitored. Where do you find wood for spars and ribs? How do you obtain fabric for wing covering? What substitutes for aircraft-grade dope and sealant? The answer was improvisation on a massive scale. Bed slats became ribs. Floorboards became wing spars. Cotton sleeping bags, the blue and white checkered issue given to every prisoner, would serve as wing fabric. But acquiring these materials required systematic theft stretched over months to avoid detection. Third, construction had to happen in absolute secrecy. German guards conducted random searches. Prisoners were counted multiple times daily. Any unusual activity triggered investigation. The team needed a workspace large enough to assemble a 32-foot glider, but hidden well enough that guards walking past wouldn't notice. However, the biggest challenge was still ahead. They needed to build not just the aircraft itself, but an entire launch system capable of accelerating it from 0 to flying speed in roughly 60 feet of castle rooftop. The logistics were mind-boggling. To construct the wings alone required over 6,000 individual pieces of wood, each hand-shaped, steam-bent, and assembled with improvised glue made by boiling down prison millet rations until they formed a paste. Each rib had to be identical. Each joint had to be structurally sound. A single weak point could mean catastrophic failure and certain death for anyone aboard during launch.
In March 1944, after weeks of reconnaissance, the team identified their construction site, a long, unused attic space directly above the prison chapel. This area wasn't regularly patrolled because guards assumed it was inaccessible to prisoners. The entrance was a small hatch in a corridor ceiling, normally sealed. The prisoners secretly loosened the screws, allowing access whenever guards weren't present. Inside, the attic stretched nearly 50 feet, just enough space to assemble the fuselage and wings in sections. But accessing the workspace was only the first step. They needed to conceal their activity from anyone below. The solution was brilliant. They built a false wall at one end of the attic using shutters plastered with mud made from attic dust. This created a hidden workshop approximately 30 feet deep. Guards who occasionally entered the outer attic space saw only what appeared to be a solid back wall. Behind it, construction proceeded daily. The real breakthrough came when they engineered their makeshift tools. Jack Best created chisels by grinding down bedboard handles. He fashioned a plane using a gramophone spring as the blade. Saws were made from metal strips scavenged from various sources. For precise measurements, they created a ruler using marks calibrated against known dimensions. These weren't professional tools, but in Best's skilled hands, they produced aircraft-quality components. Goldfinch's design specifications were meticulous. The glider would have a wingspan of 32 feet with a length of approximately 20 feet. Empty weight, 240 pounds. Loaded with 2 men, roughly 560 pounds total. Wing design utilized a Clark YH airfoil, a proven shape that Goldfinch remembered from his RAF training. The aspect ratio of 6.4 would provide adequate lift at low speeds while maintaining controllability. Control surfaces included full ailerons, elevator, and rudder. The structure was remarkably sophisticated. Wing spars ran the full span with compression ribs every 12 inches. Cross-bracing provided torsional rigidity. For the wing fabric, they discovered that sleeping bags, when carefully unpicked and resewn, created surprisingly strong covering material. The blue and white checkered pattern became the glider's distinctive appearance. To seal and tighten the fabric, they applied their homemade millet glue, painting it on in thin layers.
As it dried, the fabric shrank and stiffened, creating a taut aerodynamic surface. Control cables were fabricated from electrical wire, stripped from light fixtures and other equipment throughout the castle. Turnbuckles for tensioning were impossible to manufacture, so they created adjustable connection points using wood and metal fittings. The launch system represented pure engineering creativity. Since gliders need airspeed to fly, but the rooftop offered no runway, they designed a catapult mechanism. A metal bathtub, originally used for storing coal, would be filled with approximately 200 pounds of concrete. This tub would be positioned on a platform 5 stories above the courtyard, attached via a pulley system to the glider sitting on the chapel roof above. When released, the falling bathtub would pull the glider forward along a short runway made from tables laid end to end. Calculations suggested this would accelerate the aircraft to approximately 30 miles per hour, just above stall speed, before it ran out of roof and launched into free flight over the valley.
Construction began in earnest in April 1944. A rotating team of 12 prisoners worked in shifts, with lookouts posted to warn of approaching guards. Work could only proceed when conditions were perfect: daytime, when most guards were occupied elsewhere, and when noise from other prison activities masked the sounds of sawing and hammering. On average, they managed perhaps 2 hours of work per day, though sometimes entire weeks passed without safe access to the workshop. The tedious nature of the work tested everyone's patience. Creating a single-wing rib required shaping a piece of floorboard to precise dimensions, then steaming it over a kettle filled with water heated by an improvised stove to make the wood pliable enough to bend. This process took roughly 30 minutes per rib. They needed 64 ribs total, 2 complete wing panels. Do the math. Approximately 32 hours just to produce the basic rib structure, not including fitting, gluing, or bracing. Security protocols were elaborate. Materials were smuggled to the attic in small quantities, hidden under clothing or inside hollowed-out books. Prisoners created distractions during guard counts to provide cover for workers slipping into the attic. Sawdust and wood shavings were collected meticulously and either burned in prison stoves or flushed down toilets. Nothing could be left as evidence. The scale of coordination required was extraordinary. Dozens of prisoners who weren't directly involved with construction still participated by running interference, creating alibis, or simply keeping watch. As months progressed, the glider took shape. By October 1944, both wings were complete and hanging from the attic rafters. The fuselage was nearly finished. Control surfaces were in place and functional. The team conducted ground tests of the control systems, verifying that stick movements produced appropriate responses from ailerons, elevator, and rudder. But this was only the beginning. They still needed to complete assembly, construct the launch mechanism, cut a hole in the roof for runway access, and execute the escape itself, all without detection. However, in December 1944, the British War Office transmitted a coded radio message to all Allied POW camps. Hitler had issued orders that any recaptured prisoners attempting escape would be executed rather than returned to camps. The Colditz prisoners debated their next move. The glider was functionally complete, but was it worth risking execution? They decided to wait for better conditions, perhaps as Allied forces drew closer and German authority weakened. What they didn't realize was that time had essentially run out. The war in Europe was entering its final months.
On April 16, 1945, the U.S. First Army reached Colditz Castle. American soldiers entered the gates to find hundreds of Allied prisoners, many of whom had been captive for years. Within hours, the secret of the attic workshop emerged. Prisoners led American officers up to the hidden space and revealed the Colditz cock in its partially disassembled state. The sections were brought down to the attic below the chapel and temporarily assembled so prisoners could see the completed aircraft before liberation dispersed everyone. Lee Carson, an American war correspondent attached to the liberating force, took the only known photograph of the original glider on April 15th. The image shows several prisoners standing beside the assembled aircraft, their expressions mixing pride and relief. Within days, as Soviet forces established control over the region, the glider's fate became uncertain. The castle fell within the Soviet occupation zone, and requests to retrieve the aircraft for historical preservation were denied. Most likely, the Colditz cock was dismantled or destroyed during the immediate post-war chaos. Only that single photograph and Bill Goldfinch's carefully preserved plans survived. But the real breakthrough came decades later. In 2000, British television tested whether the design would actually have worked by constructing a full-scale replica using Goldfinch's original drawings. The project culminated in 2012 when Channel 4 commissioned another replica for their documentary Escaped from Colditz. Aviation engineer John Lee piloted the glider during test flights at RAF Odiham with Jack Best, Bill Goldfinch, and several other Colditz veterans present as honored guests. The launch simulated the original plan, a towed takeoff to replicate the catapult acceleration. The result? The glider flew perfectly. It was stable, controllable, and capable of covering the necessary distance. Engineers analyzing the design concluded that the prisoners' calculations had been remarkably accurate. The wing loading was appropriate, the control surfaces were properly sized, and the structural integrity exceeded minimum requirements. Had the launch been attempted in 1945, it likely would have succeeded. Two prisoners really could have flown over the walls of Colditz and landed safely in the valley beyond.
The Colditz cock represents far more than an escape attempt that never happened. It stands as a testament to human ingenuity under extreme constraints. The prisoners didn't have formal engineering resources, manufacturing facilities, or even basic tools. Yet they designed and built an airworthy aircraft using only prison materials and improvised equipment. Modern aerospace engineers who've studied the project express genuine admiration for the technical sophistication achieved under such limitations. The design principles demonstrated remarkable understanding of aeronautical fundamentals. The choice of airfoil section, the aspect ratio, the placement of the center of gravity relative to the aerodynamic center, all these factors were calculated correctly using nothing but memory and basic mathematics. This wasn't luck. This was skilled engineering applied under pressure. The construction techniques, particularly the steam bending process and the fabric treatment using organic adhesives, showed creative problem solving that would be valuable even in modern resource-constrained situations. Beyond aviation, the Colditz Cock project demonstrates principles that remain relevant in contemporary engineering. How to design with limited materials, how to manufacture without proper tools, and how to manage complex projects under hostile conditions. Aerospace programs in developing nations face similar challenges today: inadequate resources, improvised manufacturing, and the need to achieve professional results without professional equipment. The Colditz prisoners proved it's possible. The project also revealed sophisticated project management and operational security. Coordinating 12 builders plus dozens of support personnel, maintaining absolute secrecy for 10 months, and successfully concealing an aircraft construction project from guards specifically trained to detect escape preparations required organizational discipline that many modern businesses would struggle to replicate. The false wall, the material acquisition network, the lookout systems, the waste disposal protocols, each element required planning and execution that would impress professional operations managers.
The wooden glider, hidden in the attic of Colditz Castle, never carried prisoners to freedom, but its legacy endures as one of history's most audacious engineering achievements. Three men with nothing but determination, technical knowledge, and extraordinary resourcefulness designed an aircraft that modern testing proved would have worked. They turned bedboards into wing spars, sleeping bags into fabric covering, and millet paste into aircraft adhesive. They calculated lift coefficients without calculators, shaped components without proper tools, and coordinated construction without secure communications. This wasn't escapism. This was engineering at its finest, identifying a problem that seemed impossible, breaking it into solvable components, and executing a solution with whatever resources were available. Today, we call that innovation. The prisoners at Colditz called it survival. Either way, it reminds us that the most significant limitations aren't the resources we lack, but the imagination we failed to apply. If stories like this fascinate you, engineering solutions developed under impossible conditions, technical brilliance in the face of overwhelming obstacles, then subscribe to this channel. We focus on the how of military history, how problems were solved, how innovation emerged from desperation, how engineering changed outcomes. Next time, we'll explore another incredible POW engineering project, the tunnel beneath Stalag Luft 3 that required moving over 200 tons of sand and constructing an underground railway system, all without modern excavation equipment. Hit that notification bell so you don't miss it. And if you know someone who appreciates clever engineering or World War II history, share this with them. The story of the Colditz Cock deserves to be remembered not as an escape that failed, but as an engineering project that succeeded. Thanks for watching.